We mentioned before that Haskell is a pure language where everything is immutable by default and there are no side effects. But what exactly does that even mean? Consider the following Python code. Now don't worry if you don't understand Python, this example is simple enough that I'll be able to explain it to you from scratch. We define a variable named a to be equal to 0, and we define a function called add a to arg. This function refers to the global variable a, so we declare a as referring to the global within the function body. We then change the value of a, assigning it the value of a plus 1. This means change the value of a to be whatever a is now equal to plus 1. Then we return a plus the argument passed in, whatever that is. Now we call the function twice, with the same exact argument 5. The first time the function is called, it will return 6, and the second time it is called, it will return 7. This is what is known as an impure function, because each time it is called with the same argument, it returns a different value. Another thing which is commonly said regarding functional programming languages is that there are no side effects. What exactly does side effect mean? Side effects refer to the mutation of some state as a result of calling a function. So, for example, in the case of our function, every time it is called, the variable a is mutated and the value is changed. Here, you can see that as a side effect of calling the function, the variable a is mutated. So the first time the function is called, as a side effect, the value of a is set to 1. And the second time it is called, as a side effect, the value is set to 2. In contrast, a pure function will always return the same value when called with the same arguments. This is because values in pure functional languages are immutable. This means they cannot be changed once set, so there are no side effects. Now technically, Haskell has ways in which you can refer to and mutate global state, but that is an advanced topic and is kind of a last resort, and so we will not be covering it in this beginner's course. Sometimes you may also hear the term referentially transparent being used to describe a pure function. This means the same thing, that given the same inputs, the function would always return the same output. Now what does purity or referential transparency give us? Well, firstly, it makes reasoning easier. Functions are treated like mathematical objects, and so they are well suited to formal reasoning. You also don't have to worry about some shared mutable state, which could be referenced anywhere within your program, since everything is immutable. Secondly, parallelism becomes easier. With the guarantee that expressions are not going to affect one another, evaluating in parallel becomes much simpler. This video is a clip from a longer video for beginners starting with Haskell. Check that out if you would like to see all of the content. Also check out the entire Introduction to Functional Programming with Haskell course on the Learn channel. See you next time.